I'm here on Potter's Pond in South Kingstown with Dr. Rice and Dr. Rowe. And these two gentlemen do a lot of research, not only in the United States, but also in other countries, dealing with shellfish. Dr. Rice, I know you just came back from what country?
Well, I was just recently in Cambodia and the Philippines. I was at a scientific meeting sponsored by the U.S. Agency for International Development, and talking about some of my projects. And I was on in the Philippines working on my USAID project called the Fish Right Program.
And that fish right program, is it in alignment with what we do here in this country?
Yes, it is. It's largely surrounded on capture fisheries with the aim of preventing overfishing within the country, and working with fishers and the government agencies to sort of optimize their fishing regulations, build cooperation with the fishers, with the government agencies in order to prevent overfishing in the country.
Okay, and that information that you're gathering can it be applied to what we do here along the east?
Absolutely, and in fact, I take a lot of the information. For example, I sit on the Marine Fisheries Council. Dr. Rowe has, in the past as well, is basically the scientific advisors to the Marine Fisheries Council, and there is a lot of exchange between sort of the international applications and here. In many cases, the problems are the same. There's a lot of people, and their key concern is food production, which we are speaking about today, and sort of maintaining the environment so that the fisheries, the capture fisheries, are maintained as well.
So Dr. Rowe, you used to be an oyster farmer at one time.
I sold my farm 12 years ago, and now I manage an association for shellfish farmers from Maine to Texas. So I represent them on the national level and federal issues relating to regulations, dollars for research, things like that. So we were able to get, for instance, money for shellfish breeding so that we can try and develop lines of oysters that grow fast, are resistant to ocean acidification, or are able to resist disease. So, I certainly advocate for research. I organize research, but it's been a long time since I've done any research.
Well, maybe you could tell me how the situation currently is with the oyster beds in Rhode Island. How are we doing?
Well, so, when you think of oyster beds, you typically think of the wild oyster. And the wild oyster has never done very well in Rhode Island because we don't typically get good sets. In other words, the larvae have never set very well. We don't have a lot of the brackish waters, which is where the water meets the sea, the fresh water meets the sea, and that's where the larvae like to set. So even 100 years ago, when 1/3 of Narragansett Bay was devoted to oyster farming, those seed were brought in from Connecticut rivers, from New York rivers, and even from as far away as Virginia rivers, and planted in Narragansett Bay because we had the best growing environment. And so there were massive shucking houses with 3-story piles of shell lining the east side of the bay. It was one of the biggest industries in the state. That went into disrepair when we invented the flush toilet, and they hadn't quite figured out things like sewage treatment. So a lot of people got sick, and then we were trying to dabble in things like petroleum refineries. And we hadn't quite figured that out either. So all of the oysters in the bay started to taste like oil. So the industry went into disrepair in the 20s, and then we have succeeded in reviving the oyster farming industry, really starting in the 80s and 90s, using new technology, hatchery reared oysters. and we're able to use hatchery-reared oysters. And certainly the invention of plastics, of all things, was really integral. When I started out, show you how old I was, we were painting chicken wire to get 2 years out of it, because you have to keep the crabs and the starfish from eating your oysters. Everybody likes to eat oysters. So it was the invention of plastics, vinyl-coated wire, plastic mesh bags, that really allowed this industry to blossom. And we're seeing an explosion of interest. Our industry, oyster production on the East Coast, is growing at 10 or 15%, 20% a year.
We all know that the temperatures are getting warmer in the water. And how do you think that's affecting the shellfish?
In terms of shellfish, there's going to be a number of things that happen. One is the water itself is going to cause the oysters to grow slightly faster, which is kind of a good thing. But on the other hand, it will cause the oyster predators to grow faster as well. So there's sort of a problem of different types. The warming will also have effect on the food of the oysters as well. There's going to be sort of changes in the rainfall patterns. The changes in the rainfall patterns will have effect on the phytoplankton food for the oysters. And quite frankly, there's going to be a sort of a problem of, and we're seeing it now, we're in the middle of it, more frequent and stronger storms that could potentially sort of break through the barrier beaches and rapidly change the character of this pond.
Managing our fisheries is always a challenge. Shellfish can't get up and run away, so they're an easy target. We have a habit of overfishing, but we can protect, and we can also replant. So a number of my growers are involved in constructing restored reefs. So we can spawn oysters in a hatchery, bring in bags of shell, the larvae set on the shell, and then we can grow those oysters, and so there'll be a shell with 10 baby oysters on it, spread that on the bottom, and over a couple of years you'll have a new oyster reef. And if we can protect that from being over-harvested, we can have that habitat, which is useful in many regards, because the oysters preserve water quality, they preserve water clarity, they remove nitrogen, excess nitrogen from the waters. You're providing habitat for juvenile fish and crabs and the base of the food chain, really. Restored oyster reefs are tremendous in terms of preventing coastal erosion. As sea level rises, a lot of our marshes and shorelines are being eroded. If we can put out oyster beds, those oysters actually grow on top of each other, and they can provide a little bit of stability and slow that erosion process down and slow down the effects of sea level rise. And there's also, benefits to the water quality, to the fisheries habitat. And then, what we can do is we can grow the food on farms rather than harvesting it out of the wild, allow those reefs to proliferate, and we can grow oysters that are selectively bred to resist disease. We can grow oysters that are selectively bred to resist the acidified waters of the future. So as we increase the amount of CO2 in the air, it dissolves in the ocean, creates carbonic acid, and it drops the pH of the ocean. And if you remember your chemistry, a low pH will dissolve the shell. And it's not really too much of a problem for an adult oyster, but that dust speck larvae of an oyster that's swimming around trying to find a home for 2 weeks, it can be impacted by low pH. And so what we're able to do, is breed animals that hopefully will be resistant to the low pH of the future. This is a species that grows from Texas all the way up to Canada. It's incredibly resilient. So I know they can grow oysters in Texas. So I'm not too worried about being able to grow them. But what I do know is we're going to see a different host of predators, like Dr. Rice mentioned. We're also seeing a different host of parasites. There's many different parasites that can kill oyster beds. And we've seen them spreading up the coast as the water's warm.
Dr. Rice, the difference between genetic and GMO, just so people understand that there is a difference.
Okay, there is a difference to some extent. The terminology GMO, or genetically modified organisms, another term for this is bioengineered organisms, and that's actually a more precise term. And what that is to take sections of the gene, the DNA, from one organism and insert it into another. So, for example, there has been some work in fish to insert the genes of certain types of Antarctic fish that have what are called antifreeze proteins that allow fish to survive better in colder water. This is very, very common throughout agriculture these days, and a lot of the grain crops around the world and soybean crops are genetically engineered or bioengineered organisms. What Dr. Rowe was referring to in terms of basically doing the genetics is selecting organisms that they have traits that you want to pass on to their offspring and make for better breeding. And this is for terrestrial agriculture or animal husbandry. This has been going on since the real Green Revolution, back when people were beginning farms and changing from being hunter-gatherers, and is probably the most important sort of technology that humans have had is this ability to do plant and animal breeding to enable agriculture.
If I could just add a little bit, we're very proud of the fact that we don't need to use any fertilizers, we don't use any chemicals, we don't use any feeds, we don't use any herbicides, we don't use any genetically modified traits. So we probably have one of the most sustainable proteins on the planet, and I am very proud to be representing a group that can say that. It's just really marvelous that we can really say, quite honestly, we have probably one of the most sustainable proteins with the lowest greenhouse gas footprint of any protein on the planet.
Yeah, it's very important. Dr. Rice, Dr. Rowe, thank you very much for coming out today and spending time with us. I know you have busy schedules, but I really appreciate it.
Alex, it's been a pleasure.
Thank you.
Absolutely, yes.
Thank you.